This is the extension video to 4.3, Areas of Composite Figures. In this video, you will learn how to find the area of composite figures. Composite figure is made up of triangles, squares, rectangles, and other two-dimensional figures. Here are two examples. Here we have a triangle and a rectangle. On this side, we have a square with a trapezoid. To find the area of a composite figure, separate it into separate figures with areas you know how to find. Then find the sum of the area of those figures. You just add them together. In example 1, you're not given any dimensions on the sides. The first thing we need to do is isolate the two shapes that we have. I can see a parallelogram or a rectangle, and I can see a trapezoid. So first I'm going to write the formula, the two formulas that I need to use. So on the left I have my parallelogram, and on the right I have my trapezoid. Alright, so I have a base and a height for my parallelogram. It looks like my base is 1, 2, 3, 4. And my height, 1, 2, 3, 4, 5, 6. 4 times 6 is 24. I'm going to say units squared. And then let's look at the trapezoid. I have my two bases that are parallel to each other right here. So my bottom base is 1, 2, 3, 4, 5, 6, 7, 8. That's going to go in the parentheses. My top base is 1, 2, 3, 4. The height is how tall it is, perpendicular. That's from here to here. 1, 2. So I do what's inside the parentheses first. 8 plus 4 is 12. And I still have the 1/2 and the times 2 on the outside. So 1/2 times 2 times 12 is 12 units squared. But I'm not done because I'm actually finding the total area of this composite figure. That means I need to add the 24 units and the 12 units together. And I get 36 units for my final answer. Sometimes when you're trying to find composite shapes and figure out which ones are best to isolate, you have to see the information that you're given. This may look like it could be a parallelogram and a trapezoid, or a triangle and a parallelogram and a trapezoid, or a couple triangles, but with the information you're given, you're best off isolating this parallelogram or rectangle and this triangle. So the formulas I need are here for my parallelogram and this for my triangle. So let's do the parallelogram first. My base is 40 and my height is 70. 40 times 70 is 2,800 yards squared. And if I look at my triangle, I have 1/2, and this is going to be, since these meet how they do, this is a right angle here. So 1/2 times the base, which is 40, times the height. Well, gosh, I have to figure out that height, don't I? Because this 50 here, that's not a height. The height has to be perpendicular to the base. Well, I know that from here to here is 40. And I know that from here all the way to here is 70. And that's all the way, that's across from that. So from here to here, that must be 30. That's my height right there. Okay, so 1/2 times 40 times 30. Let me punch that into my calculator. 0.5 times 40 times 30. 600 yards squared. Okay, still not quite done because I have to add those two together. 2,800 yards squared and 600 yards squared. 3,400 yards squared is my total.